Hello everyone, my name is İsmail Erdem Yapıcıoğlu. I'm currently a sophomore mathematics student at Bilkent University. Today I will present my Physics 102 laboratory project, which is measurement of the electric constant of a liquid using a cylindrical capacitor. For this experiment, I used a multimeter for precise capacitance measurements and a tin copper sheets to form an inner and outer cylindrical plates, a plastic container to hold the setup, a strong tape, a ruler for accurate liquid height measurements, and three different liquids which are castor oil, olive oil, and isopropyl alcohol. The goal was to measure the dielectric constant of these liquids by examining their effects on a cylindrical capacitor's capacitance and to confirm the theoretical relationship between the dielectrical properties and change storage capacity. A cylindrical capacitor consists of two concentric cylinders with an electric field between them. Its capacitance depends on the inner and outer radius, which are 2 centimeters and 4 centimeters, respectively, and the liquid height and the dielectric constant, which shows how a material reduces the electric field compared to a vacuum. The capacitance is given by the formula where C is the capacitance, K is the dielectric constant of the liquid, epsilon zero is the electric constant, L is the height of the cylindrical capacitor, H is the height of the liquid within the capacitor, R1 is the radius of the inner cylinder, and R2 is the radius of the outer cylinder. I shaped the copper sheets into two concentric cylinders and placed them in a 4 centimeter tall plastic container. The inner cylinder has a 2 centimeter radius and the outer has a 4 centimeter radius. I poured the liquids between the cylinders to heights of 2, 3, and 4 centimeters, measuring the capacitance at each level with a multimeter. Between tests, I carefully dried the container and the sheets to prevent liquid mixing. I measured the capacitance for each liquid olive oil, castor oil, and isopropyl alcohol at liquids height of 2 centimeters, 3 centimeters, and 4 centimeters. Using these measurements, I calculate the dielectric constant and compare them to their known results to see how close I got. Starting with olive oil at 2 centimeters high, I measured the capacitance of 4 picofarads, which gave me an experimental of 2.49 with 19.7% error. At 3 centimeters, things worked out perfectly, and I measured 10 picofarads, leading to a matching value with the theoretical one. At 4 centimeter, I measured 13 picofarads given a K of 2.62 with a 15% of error. For castor oil at 2 centimeter, I measured 9 picofarads with 19.4% error. At 3 centimeter, I got 17 picofarads, which was 12.1% error. At 4 centimeter, I measured 19 picofarads with an 11.1 error. These were consistently higher than I expected, but still within a reasonable range. For isopropyl alcohol was the closest one. At 2 centimeter, I measured 32 picofarads with an 8.7 percent error. At 3 centimeter, I measured 49 picofarads, leading to a 9.8% error. At a 4 centimeter, I got 63 picofarads with 7.1% error. Pretty consistent across the board. Overall, the experimental dielectric constants were fairly close to known values, around 3.5 for olive oil, 4.7 for castor oil, and 18.3 for isopropyl alcohol. My errors range mostly between 7 and 20%, with olive oil at 3 centimeters being the only perfectly matched, which got me thinking about what I went wrong in other measurements. During the capacitance experiment, I faced a few issues, and one of the issues was keeping the inner cylindrical perfectly centered. Even a slight tilt could mess the electrical field and throw off the capacitance. Another problem was switching between liquids. Despite my efforts to dry the container and copper sheets, there might have been some leftover drops that mixed with the next liquid, slightly changing the electrical properties. Also, when pouring the liquids to exact height like 2 centimeter, 3 centimeter, I was taught that avoiding tiny millimetric errors. And since capacitance depends on the height, those small mistakes added up. Finally, the multimeter itself wasn't perfectly. Sometimes the wiring on the precision could have caused minor deviations. By being extra and careful and checking and over and again, I managed to keep the errors between 5 and 10% mostly. These experiments successfully demonstrate that the capacitance of a cylindrical capacitor increases proportionally with the dielectric constant of a material between the plates. The theoretical models was verified with higher accuracy and the findings strengthened my understanding of the role of the electrics in capacitor design and operation.